Okay, again, Mike Briles with Fluke Biomedical at Medicend, Dallas, Texas, and we're going through the Fluke Biomedical QED6 analyzer. Okay, with it, that the QED6 is available in 3 different configurations. Base model is just simply for defibrillator testing, able to do the defib energy, cardioversion testing, basic work there. Second model is the QED6M, has all the base model features plus an extended ECG library, more series of waveforms plus the auto sequencing capability, and the QED6H, which has all M features and adds the ability to do transcutaneous pacemaker testing also. And basically all of those are identical in look, and you just simply can discover which one it is primarily by looking at the menu. And as it says, this is the 6H version, so this has the basic pacer testing capability too, in addition to the defibrillator testing ability. Okay, we're going to be doing is testing the Physio Control LifePak 8 defibrillator unit. This is a monophasic defib unit with it that does have energies up to 360 joules. So with the analyzer, that to run those tests, you are able to measure it obviously with the QED6H. F1 is the energy push button on main menu 1, and with that, you then have to make sure you do have the level control or the range in the right switch in the right position. 2 switch positions for the defib, values over 100 or values under 100, or for the pacing capability. Okay, so with this we're going to be going first off at lower defib energies, and that'll be values under 100 joules. Again, you're not going to damage the analyzer if you have it in the lower range and hit it with 360 joules. The same high voltage attenuator is always in the circuit. It just will simply overrange and display an overrange on the LCD readout. But again, too, you will also get a more accurate reading if you're measuring low energies if you go to the 100 joule position of the switch. So we're going to start off on the basics, lower energy test, leaving it on the 100 joule range. And as you can also see, that we do always output an ECG waveform during this test, and with it you can go in and change it just basically to fit the different types of defibs, and you could just guideline or custom select a waveform specific to the type of defibrillator you're going to be testing. This is a manual defib with no interpretation capabilities, so it's not really being used, but just wanted to show you that initially it will output a normal sinus ECG at 90 beats per minute, or for testing the automated units, it will output a VFib waveform, and then also VTAC, and several different selections of VTAC. Or the basic VTAC at a lower rate. Here's a higher rate VTAC, and then a VTAC 3, which is then the, as we discussed a little bit this morning, this is the polymorphic or the irregular rate wide QRS complex VTAC, and this is the one that you would use for testing the Philips FR2 style defib. So it is something that has a bit more of a random amplitude and a little bit more of a various R wave configuration. And then also we do have a few waveforms in there that for use for testing the automatic defibrillators to make sure that they do not discharge. Obviously, if you sense an asystole or a zero, that's nothing for the automatic defibrillator to deal with. It doesn't have to. It's not designed, to work or to be interactive with that selection. And we just circle back again to the initial selection, of the 90 beat per minute ECG. So I'll just leave that one on for right now, but just simply turn the volume down a little bit. Okay, so we just, right now that we are in the energy menu, tell that by it's right there on the top screen, and it does show you that there is a spot that will display energy as soon as we do charge and then discharge the defib into the analyzer. So for right now, I'm just going to start off at some low energies. Let's go down to 20 joules. And this does have the separate charge control on the paddle. Charged up to 20. Get a nice firm, connection to the electrodes, and discharge. So we are set at 20 and reading a nice 19.2. So we're in good shape. Okay, this is a more conventional application like we've seen. These are the older, mechanical paddles. The analyzer is also compatible where you can plug in adapters for the different disposable electrode sets too. Okay, let's go up to a little bit of a higher range. Let's say up to 200 joules. As I said, you should just go to the higher range here. Okay, charger up. Good physical firm contact. And discharge. So 198.9 joules. They're looking in good shape. Okie dokie. So we can then go all the way up to the full energy. Now let's do one of those. Let's just give you an idea. Okay, 364.9, again in good shape. And you can then push the play button, and that will then discharge or replay the waveform that you have stored in the analyzer. And that is the waveform for the monophasic display discharge defib. So again, it's a Lown waveform, red mark waveform, I should say, and that you are looking at a higher single phase pulse, and you would just be wanting to see that there weren't any major gaps or glitches in the waveform itself. So just another way of checking the waveform quality of the defibrillator. So you have a marker of the actual energy level and a bit of an idea on the waveform quality is looking at that replay. Okay, now also the other energy type tests that we were talking about. That we have what's it's called the charge test, and this would be a matter of just going up to the maximum level available in a defibrillator, this being 360 joules, And with this, that typically that you're looking for values of under 10 seconds for the defib to charge and discharge on that 10th attempt. And typically that would be with it, like I said, running on battery operation. We'll just leave it plugged in for this demonstration. Okay, so hit charge. And now we're just getting ready to start the test. So we'll hit the charge button here and the start here simultaneously. Get these up here on the electrodes again, push the buttons in. Just made it. 9 seconds. So that is then a charge time value, and allows you to just make an easy test, easy measurement without having to try to grow a third arm to hold your stopwatch. And then for the that was the charge time, 9 seconds, and the energy was 366.6. So again, it's delivering the proper energy at the higher levels, and it's also discharging within the 10 second time period. Possibly it might be, that, do you have a program as far as that you charge them up before you ship them then, or good.
Or you replace batteries.
Better yet, yes. That's always the big problem with these things.
New batteries.
Oh, definitely. Good. Okay, so got a good operating defibrillator, good energy levels, and also good charge and discharge times. Now we're going to run the cardioversion test, or a synchronization test, as we had talked about. Okay, that's under the main menu 1. It's under sync, and with that, it does generate then just a normal sinus ECG. And at this point, if I were to charge up the defibrillator and discharge it without any synchronization at all, who knows what that timing would be between the two. There would be nothing to tell the defib when to discharge. So with this, then on the defibrillator, you do have a synchronization control or a push button. And once you do push that, first off, you get an indication on the defib that it is in a synchronization mode, and that also you do get a high intensity blip on the ECG waveform. So you can see sometimes, it is riding at different spots on the ECG. It just depends when it does, sense the wave. So if we were to pop up the amplitude a little bit, okay, then it is getting it on the leading edge most of the time, on the ECG. So just as long as it's not, down far, low amplitudes or negative, or not on the P wave or obviously the T wave. And again, too, regardless of the settings, it's still going to be somewhere typically within the R wave complex. So at the lower amplitudes, we seem to be getting a good indication, except for when I mentioned it. So that looks pretty good. So at this point, then, the defib will only discharge when the buttons are pushed and one of those markers has come through, and it does sense that ECG. So sync light is illuminating and flashing at the ECG rate. So just to make it a little easier, the defib should discharge when you hear one of those beeps. So first off, we'll charge it up. I'm at 50 joules, and I went down to the lower range. Now, as soon as I press the buttons it will discharge with the next ECG. And I'll tell you when I push them. Okay, and now. Okay, so it discharges, and then the ECG waveform comes back up, and we display the time. The QED6 is a little different from other analyzers that we display both the time from the Q wave, that's the initial contraction of the right ventricle, and it also displays the time from the peak of the R wave. So since the Q wave comes first, the time from the Q wave was 57.6, and from the peak of the R wave, it's like 28.4. So it just means that it has discharged, after the R wave, and it's within a safe range. As we talked about before, typically you're looking for numbers that are within 40 or 50 or 60 milliseconds following the peak of the R wave. So we well are within that range. I know that some defibrillators, some of the ones, especially the solid state transfer relay units like the MRL, some of their Model 50s, the PIC 50s and PIC 30s. Those sometimes they will be able to discharge prior to the R wave, and in that case, you're going to see a reading that's obviously a much smaller value on the analyzer. Okay, so at this point, whenever you run the test for the synchronization, that after you discharge, the defib will automatically revert back to a instantaneous discharge mode of operation. So now it's ready to go for an emergency use. And if you just simply wanted to run the synchronization test again, just re-hit the sync button. Marker comes back up, and again just pop up the amplitude, set it at a energy. Typically the tests are done under 100 joules, and just charge it up. Nice firm connection, and it just simply overwrites the readings, and very repeatable. 28 milliseconds from the R wave, 57.1 from the earlier Q wave. Okie doke. Okay, let's hold for a second.
1001, 1002, you ready?
Okay, the couple of other tests that you can do for the defibrillator tests. Go back up, escape up to the main menu 1, and you can go in and measure peak voltage and peak amperage. Remember, this is a very high energy device, so you are going to be looking at very high levels of voltage and current. And with it too, that this measures the initial peak and gives you that energy value, and then we have the over, which will simply give you any energy or any voltage or current within the second lobe of the discharge. Remember before, when we had that playback waveform, there was a little bit of a negative. With the monitor, you get a little bit of a exaggeration of that because of the the low end frequency response of these things by design aren't that good, because you don't need DC response, because this muscle tremor and other noise would just give you more artifact. With that poor low frequency response, you don't get the resolution on the low frequency. So you will see a little bit more of a pulse in that second lobe, but to get a good measurement of it, you could go to a direct DC-coupled scope to look at it, or just simply look at the over reading here, and that will tell you what the component is of that second lobe or negative lobe. Okay, so just kind of prove the point. We'll go up to the full energy capabilities. We're going to for a full 360 joule discharge. And there we go, 60 amps right on the button. That's 60 amps through a 50 ohm load. And very little overshoot, only 7 volts. That's 7 volts out of 3,000, so very minor overvoltage. And that is a test you would only do for a monophasic, and that's something that defibrillator, that was something that was spec'd by Physio Control quite a while ago. Not something that's really done much, but again, good troubleshooting tool for the future. If you were to see, defective readings or something out of the ordinary, you could push the button and see just simply what was there. Between looking at those readings and then just going back to that wave menu, it would just give you something else to try. Okay, so we've done energy, we've done synchronization, we've done peak, and then just basically the wave. It's broken down into 3 different sections, and these ECG features are in the QED6M and the 6H version. The base model doesn't have this capability. Okay, so all of your normal sinus ECG selections, 30 beats per minute, 60, 120, 180, and 240, and then this goes back and wraps around back down to 30. Okay, performance waveforms as what you would be looking at for looking at gain and damping. This waveform is good for looking at the low-end frequency response and gain. It operates very similar to what you would have with the 1 millivolt internal test, cal test for the unit. So go to diagnostic. Yeah, there you go. There it is, a little bit better. So we're looking pretty good. It's we're looking at a 1 millivolt, square wave. And again, the low-end frequency response of the monitor is by design, doesn't go down that low, so you will have, that fast discharge decay of the square wave. Go again to different waveforms for checking low-end frequency response. You're looking at basically over a 4-second DC pulse, and you're just looking to see how long that the system will hold a DC or low frequency value. And then band pass testing, looking at either diagnostic mode or your monitoring quality mode. 10 hertz should come through at at a millivolt. So 10 hertz, that's where a lot of your ECG data, your waveform content does exist, and that response should be relatively flat. 40 hertz, typically a 3 dB down point for your monitoring quality on your monitor, so you can see the response is greatly reduced. So you can barely see any of that component, even at the faster sweep rates. 50 hertz would be your notch filter test for your international devices that are being powered off of a 50 hertz power system. and 60 hertz. So it is a lot more attenuated at the 60 hertz. So obviously this one's set up, for U.S. operation. 100 hertz, that's your 3 dB down point for diagnostic quality, since the monitor shows and basically the monitoring quality, the response is already turned way down to practically nothing, just simply to avoid any problems with noise generated by line frequency or by motion. And the monitoring quality position, people are more so concerned about just getting a basic ECG to see if the person has any rhythm whatsoever. They're not as concerned with the waveform shape itself. Just a matter where does the ticker have a output or not. 2 hertz triangle wave, nice waveform for checking the linearity of your recorders and your monitors. Also too, with the waveform, if you have any notching based on it, if you're losing any of your least significant or even some of your most significant bits in your A to D converter, this is a real good way to find it out. That you would see, this is an 8-bit waveform, so you see a little bit of notching just simply from our waveform and from the conversion within the monitor itself, but there's no major gashes or breaks in the waveform. And see, you're getting a good trace. I'm also using up all your paper. Okay, and then we're just back to a very basic pulse waveform, at 30 beats per minute and one at 60. So just a quick check, just for looking at a rate meter evaluation. And it then revolves back around to the first square wave. So just for the course of looking at the waveform response, using a couple of different waveforms, that you're able to get a good idea or a good handle on the frequency response of the device, the gain and damping adjustments on the recorder, and the linearity of the strip chart recorder monitor, and the ability of the rate meter to work at a wide range of different signals that you will see. Okie doke. With it, that concludes the basics on the QED6H for ECG and for defibrillation. The physio control, that LifePak 8, it does have a capability with a cassette where you plug that in there, for doing pacing, but we don't have one, so we won't be doing, those measurements. But just to give you a quick demonstration, I think we're just looking at going up to the pacer position and going to main menu 2. Now we can go in to pace. Aha, we have one. Here we're going to have to make up an adapter to make it work, but here we go. I can, for the LifePak 8, just like a rifle. That then gives you the pacer capability. No, hold it. This is the defib cassette.
Oh,
There's another cassette that's for pacer. This just simply allows you to use the fast patch defibrillation electrodes. So we've added also to this the needed adapters that you would need, for running these. We have an adapter that you can plug into here and then attach these to it, so you won't have to sit here and try to do something dangerous. Okay. One other item for defib testing, we also do provide these little adapters, and Contrary to popular belief, this isn't for changing stations, and this is the amplitude or the volume. This is for the internal defibrillator discharge paddle plates. It's just basically, this is a more of a convex type surface, and you can put the paddles right directly on these, and to make a measurement. Okay, quickly for the pacer, you have the ability to measure the pacer. Shows the current level, the output amplitude, the voltage peak, and the width in milliseconds, and the rate of the pacer. There's also the other tests for refractory period testing, just looking at the ability of the pacer to be interactive with a patient whose ECG, basically is intermittent, or it does occur at different intervals following the pacer's waveform spikes. Again, with that, making sure that if the patient has any normal ECG activity, that the pacer does sense it properly and doesn't output any pacer spikes at the improper times. Okay. Also, there are some print functions with this, and it does work just simply with the older conventional Centronics printers. We do sell the some of those units. It's the Seiko 1414 printer. We do sell a little thermal printer you can use if you are looking at documentation, of the tests that you do perform. Okay, well, that pretty much covers it. Any questions or any specific defibs that you're testing?
No, it's about the real situation in Tehran with that defibrillator. I didn't catch the synchronization.
The purpose for the test?
Yeah.
Okay.
Because here you can synchronize the discharge with the monitor, but in Tehran, what's the
What's the clinical purpose?
Yes.
Or the
No, it's not a clinical purpose. How do you synchronize the moment of that discharge?
Okay. There's no really no need for you to be concerned with that, because what will happen is the defibrillator isn't discharging when you push these discharge buttons down. It will only discharge at this point when you have those buttons pushed down, and then after that the ECG comes through, then it will discharge. So in this one condition, the defib isn't discharging immediately when you push the buttons. It's charging only if you've got the buttons pushed, and only when the ECG waveform comes through, then it will do it. I can demonstrate that a little bit differently. It'd be easier for you to see it. You can go to the ECG mode. Okay, wave. Go into ECG. I'll do a 30 beat per minute ECG. And right now, to run the synchronization test to get numbers of delay, you have to run the synchronization test using that 90 beat per minute ECG. But it also works if you output an ECG to this device. This will run in a synchronization mode, but it won't give you numbers over here for synchronization. All I just want to do is show you the time difference from when I push the buttons down to when the defibrillator discharges. So right now, we're running a very slow ECG.
Okay.
And you can hear, when the ECG comes through,
Exactly.
and the mark is on the leading edge of the pulse. Now what's going to happen, I'm just going to put these here
Okay.
and first charge it up just to 30 joules. Now, normally if you discharge the defib, it's going to go and do it immediately. But in this case, I'm just going to wait until that ECG waveform goes by, push the buttons, and then it won't discharge until the next ECG waveform comes through. So I'll wait for one to go through. Now I've got the buttons pushed. It doesn't discharge until that ECG comes through.
Yeah, but this is a decision that belongs to the operator. I mean, the nurse or the doctor.
Oh yeah.
It's not what happens when you have a high rate of pulse. I mean, 140, 180.
Oh, it still works. Well, what happens is, this is, like I said, this is for a condition that it's called atrial fibrillation. And that waveform is basically something that's completely wrong for the patient, where that and the problem, or what's caused it, is that the atria are beating very, very, very fast, but the ventricles can't keep up with it. Now, that's mostly because in a situation where their patient has a fluid buildup in their lungs, and the heart is trying to pump faster to get more of that out of the body, to get the body to operate faster, to get rid of it. But at some point, the ventricles can't keep up with that, and the longer that goes on, the more of a problem that the patient can have, because that blood is being pumped within the heart, but it's not pumping out. So it's blood sitting stagnant within the heart. And in those conditions, that's where you can very easily have a clot, where the blood can coagulate even within the heart, where it just simply pull and lay. Then once it finally does beat, you're shipping that clot to different spots of the person's body, the heart, into a coronary artery or into the brain. So this would be a clinical decision by the nurse or the doctor to say, okay, patient has atrial fibrillation, and that waveform, has a certain look to it. They know what it is. They'll maybe try to treat it with medication, but if it doesn't, they'll say, okay, here's the heart. The atria are fibrillating. It's not being controlled at all, and only a few beats are coming through. Says, okay, let's synchronize it so when one beat does occur, that's when, bang, they cause the entire heart to contract, including the atria and the ventricle, and then they, hopefully, when it relaxes, it begins to beat back normally. So it is a clinical choice by the doctor to do that.
Yeah. No, I thought that there is a connection, electrical connection between the monitor and the defibrillator, and the moment of
Yes.
releasing the energy is established by the monitor.
Yes, it is.
Is it?
Yes, it is. Yeah, we could disconnect these two,
Okay.
and electrically there's an optical connector
okay.
between these two. Yeah. Right within here, there's some optical sensors right in there, and that does communicate that information over for the defibrillator. Because right now,
It's not.
sync won't work.
Okay.
Nobody to connect to. Sync. So it is an optical. So there is an optical connection between the two.
Okay.
I misunderstood you. Yep. Yeah, that's what I was wondering too.
No, I thought that you can, put them aside, and you look. I didn't test it, and this is the first time when.
Oh yeah. This is this older unit is something though that it does have the optical connection between the two, and some of the newer LifePak 8s has the little bus in the back where you only need one power cord. Some of the older ones, we have one of the older LifePak 8s, you have to have two power cords on it, one for the defib and then one for the ECG monitor.
I shipped out boutique defibrillators without monitors, and I was curious how they synchronize the moment when you release the energy without having a monitor. That's good.
Well, what they do a lot of times, that there's older defibs that don't even have the synchronization feature. But if they do have synchronization capability, but they don't have ECG activity, a lot of times they will use a slave scope from a bedside monitor. And that's where that 1-volt ECG level would come in handy. You could take that and input that into the defibrillator.
Okay.
It just depends on the requirements of that specific defibrillator, what type of synchronization signal it would need to discharge it.
So you have to use that defibrillator only in that room with some equipment.
Right, and it's best practice simply to have the defib and the monitoring all in one device. A lot of times that they do use a slave off of a monitor, patient monitor. A lot of times they use that for some other devices that need a synchronization with the ECG signal, it's like a intra-aortic balloon pump assist system. They'll do the same thing. But with this, I'd prefer, if they're going to run the test on me, I'd rather have the darn things together tied into one.
Yeah.
But you can then use this higher level signal to accomplish that task.
I've got it. Everything. Yeah.
Good.
I understand.
Yeah, I know some of the older ones. We can go take a look at those later too.
I shipped out 7 or 8 pieces of some boutique defibrillator.
Okay.
They were small. I mean.
Oh yeah, the Medic 4s or 5s, I think.
Probably.
Yeah.
Some.
Okay.
I was curious about what happened
Yeah.
when you don't have a monitor and think about the moment when you release the energy. So
it's like having a gun with no sights on it.
Yeah, it's like a shot,
Yeah, those are. There's not that many of those out there anymore. Some of the automated defibs will have very limited monitors on them, but they're not used for any synchronization purpose. Just one shortcoming, and this is just simply, it's more of a matter of just the advent of new design of medical equipment. There is a new defibrillator that's made by Schiller, Switzerland, and that with this, it's, as they call it, it's a pulsed biphasic waveform, uses a 5 kilohertz square wave that's output under an envelope of the biphasic. So it'll burst 5 kilohertz of positive square waves, and then do
under that envelope.
Yep. Then do 5 kilohertz at the lower. So at that point, then it is something that is an AC signal, which is something that these analyzers were not designed for. That was just simply the changes that have occurred in technology. Those units, their nickname for it is Fred, so it's any Schiller Fred biphasic defibrillators. It's a new technology. There are some white papers out there about it, though we're not compatible with either with the QED6 or the Impulse 4000. However, that the Metron QA40 and 45 that we sell, that one, it's a later design, and it is compatible with that device. So if you do come up with it up to any of those, that would be something that we'll discuss it in a couple of years.
Yeah.
Yeah, but they have a very nice line of those defibrillators, so that
are they accepted?
yes, they're being used internationally now. It's a lot of them in Europe and third world countries, because they're very lightweight, very small. There are some of them that
It's probably cheaper.
much cheaper. They're like almost like this big. Yeah, so it's almost like they put them in the doctor's lab coat pocket. But again, a waveform that we're not fully compatible with. So
You have
we got
a
some.
new project.
We have one going on, so we'll have something later next year. Okay.